Hello, everyone. This is Chris Chapa, math professor at Tyler Junior College, and this video is going to explain the solution for the week one logic puzzle, as we celebrate Math Month at Tyler Junior College. I should point out that all of these puzzles can be solved completely deductively, meaning by using clues and hints, you can deduce where the locations of the trees are, as opposed to just placing a tree and hoping that you find the right ones. Just a quick reminder of the rules. We're going to place 7 trees in this grid according to the following rules: 1 tree per row, 1 tree per column, 1 tree per region separated by dark lines. And you may notice that this is a better drawing than the one I originally posted. I did receive a couple of people's emails saying that they couldn't see the line separating the regions. And trees cannot be in adjacent squares vertically, horizontally, or diagonally. The way we're going to approach this deductively is by eliminating locations that trees can be, and eventually we'll be forced to put trees in certain places. And the way we're going to deduce where a tree cannot be is by looking for locations where if a tree was present, it would end up breaking one of the rules. For example, look at look at cell D3. If we put a tree there, then by the adjacency rule, it would take out E3, no tree there. Let's put an X. It would take out cell E3 by adjacency, cell E2 by adjacency, cell D2 by adjacency, and cell C2 by adjacency. And therefore, the region containing those 4 X's would not have a location to put a tree. Since we have to have a tree in there, that means that there cannot be a tree in cell D3. So we'll put an X in cell D3, meaning no tree there. Using similar logic, we can't have a tree in cell D4, because if we had a tree in cell D4, and this is one of the tricks of this type of puzzle, if you have an L shape, you can't have a tree in that inside corner, because if you did, then it would exclude all the cells in this region by adjacency. And since we have to have a tree in that region, that means we can't put a tree in D4. So let's put a black X in D4. Where else can we not put a tree? We cannot put a tree in cell B5. And the reason we can't put a tree in cell B5 is because it would take out everything in the region below it. It would take out C4 and C5 by adjacency, and D5 and E5 by the column rule, completely wiping out every cell in that region for a tree, which contradicts the last rule, the third rule, meaning that there must be a tree in that region. So since that would break that rule, we cannot have a tree in B5. Let's put a black square there. And using the same argument, we can't have a tree in F2, because if we did, it would take out all 4 of these, and that region would no longer have a tree. All right, so where else can we not have a tree? Well, if you notice, this region that I'm about to highlight is now an L-shaped region because I crossed out one of its cells. And so it can't have a tree on its inner corner either. It can't have a tree in cell C7. It would take out all of these by adjacency, and then the region that contains all those checks would no longer have a place for a tree. And using similar arguments as before, we cannot have a tree in cell E6 because it would take out these 2 by adjacency, these 2 by column, and then that region would no longer have a place to put a tree. It does take a little while to get used to these rules. And in case you're wondering where I've got these, there's actually an app called Parks. The name of the tree is actually, the name of the puzzle is actually Parks, P-A-R-K-S. It's not written very clearly. But like if you have an iPhone and search Parks Logic in the App Store, you can get an app that has several of these puzzles. I want to say in the hundreds. Anyway, I digress. Looking at the upper right region now, because we crossed out one of its squares, it's now an L-shaped region. And so it has the same restrictions as the other L-shaped regions, namely that we can't have a tree in its inner nook, which would be B6, because it would cross out all of these, and then that upper right region would no longer have a place for a cell. We can cross out D5. a place for a tree, I should say. We can cross out D5 because if there was a tree there, then it would cross out these by row and this by adjacency. And then that region that contains the 3 check marks would no longer have a location for a tree. Let's see, what else can we cross out? As you get deeper, you have to look harder to find some locations to cross things out and resort to some more tricks, which I'll get to as time permits or as necessary. We can't have a tree in E3 because if we did, it would take out the one to the right of it by adjacency and the 2 above it by column. And now the region with those 3 check marks no longer has a place for a tree. And so E3 can't have a tree. And now we reach another hint that we can use. Look at this region here, which already has one X in it where a tree can't be. That means that the tree in that region must be in one of these 3 squares. But because those 3 squares are all in the same column, that means no other square in that column can contain a tree. So we can't have a tree in A2, B2, or G2 because we know a tree has to be in one of those 3 regions. And because we know a tree has to be in one of those 3 regions, we know that there can't be a tree in D1 because it would take out all of these by adjacency, and then there would no longer be a place to put a tree in there. All right, so we got quite a few X's, but we still have a ways to go. Let's see if I can find any other tricks here. Yes, I cannot have a tree in F3. Why can't I have a tree in F3? Because it would take out E4 by adjacency, C3 and B3 by the same column. And now that region where I just put those check marks no longer has room for a tree. Okay, let's see. And by the way, I am solving this puzzle on the fly. I did solve it in advance of creating the puzzle, or rather I should say borrowing the puzzle from another source, from the Parks app that I just referred to. I solved it in advance to make sure that it was solvable. Of course, it was going to be solvable, but every time I solve one of these puzzles, I pretty much do it from scratch, even though I'd solved it in the past. All right, let's see if we can find some more places to eliminate possible locations of trees. Let's see, the further you go, the trickier it becomes. Looks like C4 is bad. Why is C4 bad? Because it would take out B3 and C3 by adjacency and E4 by column. And now the region with those 3 check marks no longer has a location for a tree. And now look at this 7-shaped region right here. Notice there are only 2 empty squares left in it, and they live in the same column, which means that there must be a tree in one of those 2 squares, C5 and E5. And since they're in the same column, that means there cannot be a tree anywhere else in that column. There cannot be a tree in A5, there cannot be a tree in F5, and there cannot be a tree in G5. Okay, let's see where else we can find some hints. One trick is to look at rows, columns, or regions with very limited options and see if there's anything that would cause all of those remaining squares to not be eligible to hold a tree. I found another one in B4, because if we had a tree in B4 right there, it would take out B3 and C3 by adjacency and E4 by column. And now the region with the 3 check marks no longer has a space for a tree. And so B4 cannot contain a tree. All right. Oh, I'm sorry. Go back to C5 and E5. I forgot something. I mentioned this earlier. But whenever you have a 3-square rectangle where there must be a tree, then there cannot be a tree immediately to the left or right of it, because it would, in other words, I can't have a tree in D6, because if I had a tree in D6, it would cross out these 2 by adjacency, and now that region no longer has room for a tree. Okay. And now I'm going to pull a new trick. The new trick is to look at multiple regions covering multiple rows or multiple columns. For example, consider these 2 regions here. I know that the first one has to have a tree in one of these, and the second one has to have a tree in one of these. There can only be 1 tree per column. Now, I don't know which of those regions has a tree in column 6 and which one has a tree in column 7, but collectively, their trees are in column 6 and 7, which means there cannot be a tree in column 6 or 7 outside of that region. In other words, we can't have a tree in E7, F7 or G7, F6 or G6, because even though we don't know which regions contain the tree in column 6 or column 7, we know these two regions together contain trees in columns 6 and 7. So no other region can. All right, making progress here. Got a check mark I need to get rid of. There it is. Okay. All right, let's see what else we can do. Try not to pull out too many really bizarre tricks. B7 can't have a tree, because if it did, then it would take out C6 by adjacency and D7 by column. And now this region, this little Z shape, no longer has a place for a tree. So B7 cannot have a tree. Now let's look at the upper right region. The only two squares left in the upper right region are here. One of those must have a tree, which means, and since those two squares are in the same row, then there can be no other squares in that row. So there's not a tree, excuse me, in A1, A3, or A4. And notice I still haven't placed a single tree, but bit by bit, I'm eliminating possibilities. And the minute we can drop one tree, it's probably going to set off a chain reaction, and we'll find all of them. Look at row B. Row B only has two locations for a tree, which means I cannot have a tree in C2, because if I had a tree in C2 right there, then it would eliminate those two as possible locations for trees, meaning that row B could not have a tree. Okay, let's see, what else can we look at? Not sure if you hear all my emails going doo-doo-doo-doo. Okay, look at row F. In row F, there's only two squares available for trees, F1 and F4. Is there another square that would cross out both of those as possible locations? And the answer is yes, G1. If there were a square in G1, it would cross out F1 by adjacency and G4 by being in the same region, and that would wipe out every location for a tree in row F. So we can't have a tree in G1. Okay, now look at row G. In row G, there's only two locations for a tree. So there must be a tree in one of those locations, which means that the tree for the bottom region is one of those two squares, so it cannot be in this one. Otherwise, these wouldn't have trees, and there would be no place for a tree in the bottom row. Okay, we're getting there. We're almost there. I can sense it. Look at column 2. In column 2, the only location for trees are these two squares, so we cannot have a tree in E1, because otherwise it would cross out both of those and there would not be a location for a tree in column 2 or in the region containing those two squares. Okay, are there any rows or columns with only one option left? Yes, and I should have jumped on this the minute I saw it. Look at row F. In row F, there is only one square remaining where a tree could possibly be. Now, when we start dropping trees, we can cross out any other square in the same row, column, or region or adjacent. So this is going to finish off real fast. There must be a tree in F1. It's the only space left in row F, which eliminates B1 and C1 by column, E2 by adjacency. And now look at this region. Look at the region containing D2, that L shape. The only place for a tree is right there. The column and the row, column's already X'd out. The row isn't X'd out, except now it is. And by adjacency, we can put an X here. Look at row B. The only location for a tree is in B3. The row is already wiped out. The adjacent squares are wiped out, but the column isn't. So go down to G3 and put an X. Now in the G row, the only place left for a tree is G4. And by column, that crosses out E4. In row E, the only place for a tree is E5. That crosses out C5 by adjacency. In row C, the only place for a tree is C6. That crosses out A6 by column. And the only one left is here. And those are the locations of the trees. If you enjoyed this logic puzzle and would like to try more, and by the way, I'm not getting anything from promoting this app. It's just one that I enjoy. Again, at least for iPhones, I don't know if it's in the Android store, but if you search Parks and Logic, you can get a logic puzzle. It's called Parks, and it's basically a bunch of these. There are different variations of this theme within that app, such as placing 2 trees per row, column, and region, while still preserving the adjacency rule. But it's a fun thing, and I personally think that logic games stimulate your brain and basically exercise your brain in ways that you might not normally exercise it. And like any other part of your body, the more you exercise it, the better it gets. I hope you've enjoyed this, and I look forward to making videos for the remaining puzzles.